Pop quiz, hotshot. Which is better, to have all of your memory equally slow or half your memory be faster? Which would you prefer? And the answer might be, it depends. Hi, I'm Dave Stewart. I'm an engineering manager in the Open Source Technology Center at Intel, where we're working to make Xeon the best platform for running Solaris or OpenSolaris operating system. The Intel Xeon processor has really been something that, when we think about memory, is something where we're trying to, hide the problem where it has been around with processors for years, and that's the fact that processors are getting faster and faster, and yet memory runs at a slower speed typically. So what do you do if the processor needs to do processing but doesn't have the data from memory because the memory is slower? And so the processor sits there with nothing to do, and this is a problem we call memory latency. And so if you can reduce the amount of time that it takes to access memory, why, you're going to typically speed up your performance. And so now we come into this whole area of NUMA, or non-uniform memory accesses, where we can try and use this technique to try and lower the memory latency. NUMA's been around for a number of years. I used to work for a company that had one of the first commercial NUMA processors, and but that was back in the 90s. Today NUMA is really poised to go mainstream in a big way, and so we can really use this technique to lower memory latency because all the big caches that we have, hyper-threading and all the rest. Still, it's nice if you can lower the access time to memory. So let me tell you a little bit about NUMA, and then what's unique and interesting about OpenSolaris and how it works with it. So again, this is something that's we're talking about the new Intel Core i7 microarchitecture, formerly known as Nehalem. Well, here we have old and NUMA, where the old system prior to Nehalem, we'd have a situation where we'd have processors connected to a memory controller hub, and this memory controller is really the thing that accesses memory and manages it. Well, in this sort of situation, you can see both processors have two hops, a hop to this chip and then a hop to the memory chip to get to any memory. And so, if you could eliminate this hop for at least some of the processors accessing memory, you'd actually speed things up, hopefully. And so here's NUMA, a situation where you have, here's a Core i7 processor with memory directly connected, because we've actually put the memory controller into the chip itself. But you can kind of see here that each processor has not all of the memory connected to it, but only part of the memory connected to it. Now, this is great if your processor is running instructions that need memory that's directly connected. But what if that thread needs memory that's on the other processor? Well, you're back to a situation where you have two hops to get to the memory. So you can kind of see here where this situation might improve some situations, but might actually slow other ones down. So it's very critical that the operating system get involved in this whole area and make sure that any memory you allocate actually is close to the processor that's going to run the thread that allocates the memory, right? Now, enter Solaris and OpenSolaris. Basically, there's a technique called memory placement optimization that's been in Solaris for quite some time. This basically establishes, with a knowledge of how the computer is laid out and organized, how the memory hierarchy works, it can actually make sure that when a thread gets created, when it allocates memory and it gets scheduled onto a processor, it's scheduled onto a processor that's part of a latency group that knows basically which processors are close to memory and which ones are far away. What we've done to really take advantage of this technology, both Intel and the OpenSolaris community, is really using an industry standard mechanism, ACPI, which basically describes this layout and this configuration, what are called the SLIT and SRAT tables, and so basically is able to decode where the memory is, what processor it's connected to, can tell MPO how to get at it. And what we've seen is that actually, again, depending on your workload, you can see some great acceleration based on this technology. Now, how can you get involved with this? We'd love to see your results using the new Core i7 servers as they come out, because the Solaris and OpenSolaris operating systems today have this built into them to be able to detect the NUMA configuration and take advantage of it. So go to OpenSolaris.org. We encourage you to join the Intel platform platform project where we talk about projects like this. You can look at the source code. You can try it out for yourself. You can join the community and the conversation, and then be able to improve what we're doing in terms of NUMA and the Solaris and OpenSolaris operating system.